Hello everyone. Good afternoon. I hope you all are doing well. So, first of all, let me introduce myself. My name is Rahul. Okay, and I'm your maths teacher from Avanti Fellows. Okay, so good afternoon, everyone, from those who are watching through YouTube as well as Zoom. So, thank you. Yes, Kamble, Appu fans, good afternoon. Okay, so we'll wait for 1-2 minutes so that everyone can join and then we will start the class. So there was a long gap. So we have started class after so long, right? So I hope you had a great midterm examination as well as holidays, Diwali holidays. Okay, so now we will again start the class. Okay, so I'm just waiting for few students, for few schools to join so that I can start. Okay, I hope I am clearly audible to all of you, right? And my screen is clearly visible to you. So if there any problem, you can just let me know through the chat box. My chat box is always open for all of you guys. Okay. Okay, so yeah, so before this class, we were discussing. We have started continuity, right? So continuity we have started. Like what we have discussed in the previous classes, we have discussed. Hello, Janvi Silvasa, how are you? Okay, yeah. So we have discussed till discontinuity. Okay, so what I have told you in the previous classes, I know it was 1 month back, but still this is the easy concept that we have discussed continuity. I have told you that if any function is continuous at any point x is equals to a, so what you need to do, you need to find LHL, left hand derivative, left hand limit, right hand limit, LHL and RHL, and the function value f of a at that point. So if all are equal, then we can call the function is what? Continuous. And if any of the criteria is not fulfilling, then we will say that the function is discontinuous. Okay, so simple, the function which is not continuous is discontinuous. Okay, so that thing we have discussed. So now what we will do, we will see some types of discontinuity. Okay, what types of discontinuity? Okay, so the first thing, there are two types of discontinuity, major type. That is, first is removable discontinuity. Removable discontinuity means what? In removable discontinuity, what will happen? If any limit x tending to a exists, okay, the limit is existing means LHL is equals to RHL. But there are two things. It is either not equals to f of a or f of a is not defined. There are two things can be happen. Like first case is limit x tending to a f of x. This limit exists. Exist means what? LHL is equals to RHL. And the other thing, but it is not equals to f of a. यानी function value पे equal ये नहीं है, right? LHL is equals to RHL, but it is not equals to f of a, right? So if it is happening, then we can say that it is a type of removable discontinuity. And the other thing is LHL is equals to RHL, but what we can say that f of a is not defined. It is not defined. So this is the second case. This is the first and this is the second case. Okay. So there are two types of removable discontinuity. Okay. So why we are saying it a removable discontinuity? Because in this case, if there is a case of removable discontinuity, so it is possible to redefine the function in such a manner so that the limit or limiting value will be equals to function value. Okay, so we want to make it continuous. So those kind of discontinuity which can be removed by redefining the function, in those kind of discontinuity I will call it as removable discontinuity. So removal, there are two types of removable discontinuity. Removable discontinuity. The first one is isolated point discontinuity. Okay, and the other one is missing point discontinuity. Missing point discontinuity. Okay, two types. What is missing point? Missing point means the second one, and the isolated point is the first one. Means now you can see in this case, I will show you. First one is missing. मैंने आपको फर्स्ट में आइसोलेटेड बता दिया, चलो यहाँ पे मिसिंग पॉइंट को पहले बताया. व्हाट इज मिसिंग पॉइंट डिस्कंटिन्यूटी? मींस लिमिट एग्जिस्ट बट फंक्शन वैल्यू इज नॉट डिफाइंड. ओके, सो हाउ? I will take one example. Suppose f of x is equals to x square minus 4 divided by x minus 2. And we have to find whether this function is continuous at x is equals to 2 or not. Okay. So now you know that if I will put x is equals to 2, then 2 minus 2 will become 0 and it will not define. So certainly you can see f of 2 is not defined. It is not defined because 2 minus 2 it will become 0. Right, so function is not defined. But what if I will find the left hand limit and right hand limit? Let me check whether the limit exists or not. Okay, so if I will find LHL, so we know that x square minus 4 divided by x minus 2, limit x tending to 2 minus. So if I will put 2 minus, so what is going to happen, right? So I can write like this: 2 minus h ka whole square minus 4 divided by 2 minus h minus 2, right? So what will happen? This is 4 minus 4h plus h square minus 4 divided by 2 will be cancelled out. This is minus h minus 4 will be cancelled. This is minus 4 h plus h square divided by minus h. Now if I will take h as common, minus h as common, it will be 4 minus of, we can say h by 4, right? H by 4, no problem, we can take. And this is minus h. So minus h will be cancelled out. And if you will put h tending to 0, it will come as 4. Okay, similarly, if you will find RHL, right? RHL. Similarly, again, if you will see, same thing will happen and it will be 2 plus h ka whole square like that. And after that, you will find that it is coming as 4 only. So here you can see LHL is equals to RHL, but it is not, the function is not defined at 2. So these kind of discontinuity is called as missing point discontinuity. I just wanted to draw this graph, okay, this functions graph. Okay, so if I will draw this graph, so what is happening, right? The graph will be like this. Like this it will go, and at 2 it is not defined, and then it will go like this. Okay, so what I can see, this is 4, but exactly at 2 it is not defined, so that's why there is a open a hole like that. Okay, so it is not defined. So but LHL and RHL, both side it is equal, but it is not equal. So in this case, what we can do, we can remove this discontinuity. How we can remove? Can we redefine the function by assigning a single point? एक point को हम यहाँ पे करेंगे और हम इस function को फिर से क्या करेंगे, ऐसा लिख सकते हैं, like f of x is equals to x square minus 4 divided by x minus 2 at x is not equals to 2. Only 2 point I have removed, and x is equals to 2 pe. We have defined another value, that is 4, because we know that LHL and RHL is what? It is 4 only. right? So the function is defined. Now you can see this function is continuous, right? Is it clear, Janvi Silvasa? Yes, Appu fans, everyone. Is it clear, everyone? Missing point discontinuity. Okay. Similarly, we can see isolated point. In isolated point is what? Limit is also exists. F of A is also exists. What is happening? The limit is not equals to F of A. Right, limit is not exist to F of A. So in this case, what we can do, like suppose I have written like this, F of X is equals to X if X is not equals to 1, and X is equals to 1 if it then it is 3. So now you can see, if you will find limit X tending to 1 minus, so definitely it will be 1 minus H and then it is 1. If you are taking X is 1 plus, again the if it is not equals to 1, then it is X only. So in place of X I will write 1 plus H, it is again 1. And if I will take F of 1, then value is 3. So now you can see in 1 it is coming 1 LHL RHL equal. Okay, but the function is not equals to F of 1. So in this case, this kind of discontinuity is called as isolated point discontinuity. ठीक है, इसका ग्राफ बनाएंगे तो देखो कैसे बनेगा. Like this, if we are going, so exactly at 1, this is not, but then again it is. So at 1, the value is defined, but it is not equal to 1. It is equal to 3. So there is a 1 point, but it is isolated from each and every point, and it is what? It is 3. So only at F of 1 it is 3. Otherwise, in this side and this side function is defined. So again, what we can do if we have to remove the discontinuity, I can write like this: F of X is equals to X if X is equals to not equals to 1, and if X is equals to 1, then it is 1. In place of 3, what I will write? 1. So we can remove this one. Okay. So I hope it is clear. Types of discontinuity. First is removable type of discontinuity. In removable discontinuity, there are two types. One is isolated, and another one is missing point discontinuity. Okay, now there is other type, that is non-removable discontinuity. I will not explain it that much because we have so many things to see. Okay, but I will explain you how to check. Like non-removable means simply the discontinuity which can't be removed. Okay, like finite type. So first of all, in this case, in non-removable discontinuity, the major condition in there, in this case, limit doesn't exist. In the previous case, limit was exist. Okay, but in this case, limit doesn't exist. If limit doesn't exist means what? That LHL is not equals to RHL. So there are three cases again. One is if LHL is not equals to RHL, but it is having a finite value. Okay, so in this case, what we will see? What we can say? Ki limit doesn't exist. Doesn't exist. So if it is happening like this, then we can say that is it finite type of discontinuity and it can't be removed because you can't change LHL and RHL. One value if you are getting not getting, then you can redefine, but the whole function you can't change, right? And the other one is infinite type, means at least one of two limits are infinity. Okay, it means if LHL is tending to infinity, suppose RHL is tending to infinity, so in this case we can say that this is infinite type. Okay, if LHL or RHL is tending to infinity, then we can say that it is infinite type. Like one example I will take, f of x is equals to 1 divided by 1 minus x at x is equals to 1. Okay, so now if we will find LHL, so what will happen? Limit x tending to 1 minus 1 divided by 1 minus h. So if I will take 1 minus 1, it is 0 minus minus plus, so it is h. So if h tending to 0, so definitely it will be tending to plus infinity. Similarly, if I will take RHL, limit x tending to 1 plus, so it will be what? 1 divided by 1 minus 1 plus h. So it will be 1 divided by minus h, and it will be tending to minus infinity. So now you can see LHL is also tending to plus infinity, and RHL is also tending to minus infinity. Or if suppose any one of them is tending to infinity, then we can clearly say that if this is infinite type of discontinuity that can't be removed. And the third one is oscillatory. Okay, oscillatory means the limit value we actually not sure about the value of limit, but we know that it oscillates between two finite quantities. So I will take example for oscillatory also. This is sine 1 by x at x is equals to 0. Okay, so what is happening, guys? Suppose we have taken limit x tending to 0 minus. Okay, this is LHL. So if I will take sine 1 divided by 0 minus, so definitely you are getting something like sine to the sine inside sine minus infinity. And you know that if it is infinity or 1000 times infinity, doesn't matter. Sine value is always between minus 1 to 1. Okay, this is minus 1 to 1. Okay. And then if I will take RHL 0 plus, then again it is 1 divided by 0 plus h. You can say here you can write 0 minus h, no problem. This is sine 1 by h. So again it is sine to the power infinity. Okay. So now we know that after every 2 pi, sine value is changing between minus 1 to 1. It is rotating or oscillating. Okay. But it is plus infinity, right? So if it is plus infinity, then if we'll add 2 pi, what matters? Nothing matters now, because if we will add 2 gram in 1 kg, it doesn't matter now. So similarly, if it is sine infinity, suppose, so we are not sure that suppose sine infinity is equals to 1. So if I will take sine infinity plus pi by 3, again it is appearing as infinity now. So we are not sure. We know that the value will lie between minus 1 to 1, but we are not sure what will be the exact value, because it is coming as infinity and minus infinity, right? So that's why in this case we consider that it is changing so frequently, because 2 pi, 4 pi, 6 pi we can see, but if it is going up to infinity, then we can't see, right? So in this case, we can't see, and we know that. So if you will draw the graph of sine 1 by x, na, it will be coming like this, like this, like this, like this. Okay, so that's why. So it is changing so frequently. So even if we are taking plus h and minus h, it is changing significantly. Right. So that's why in this case we will say it is oscillatory types. The limit oscillate between two finite quantity, that is minus 1 to 1, but we are not sure ki what is the value. Is it clear, everyone? Janvi Silvasa, Janvi Rajkot, clear है सबको? Okay. Okay, so now we can see. Okay, very good. So now the algebra of continuous function, the very basic thing. If two functions are there, if both functions are continuous at x is equals to a, then if any constant is multiplied with this function, then that function will also continuous. if we are adding two continuous function or subtracting two continuous function, then the resultant function will be a continuous. If are multiplying or dividing, that you already know, right? So these are the algebra of two continuous function. What if, stupid guys, what is happening here? Yeah. Now the other one is if one function is continuous and other function is discontinuous. So if one f of x is continuous and other function is discontinuous, then if we will add or subtract both function, the resulting function will be discontinuous. Okay. So remember these type of formulas like concept, just remember करो तो कभी कभी क्या होगा कि आप आसानी से इसको कर पाओगे. The second thing is, if we are multiplying one continuous with discontinuous or dividing one continuous with discontinuous, so it is not necessary that it will always come as discontinuous. It can be continuous too. Just like one example is given, you can see here, okay? But I hope you can't see me because now electricity is gone, so my face is not visible, I guess. Okay, but I hope the screen is clearly visible to you. Okay, so f of x is x. We know that this is a continuous function. Okay, and gx is sine 1 by x. We have just seen it is discontinuous function. Okay, so one is continuous, other one is discontinuous. But if I will take f of x into g of x, so this will become x into sine 1 by x, or other one will become x into 0, that is 0. Okay, so now we will check the continuity of this. So we can see, we know that this value is hanging between -1 to 1. But one thing is sure, that it is a finite quantity. So if I am checking the continuity at x is equals to 0. So if I will put 0 plus something, so the whole quantity will be coming as 0 only, and it is 0. So limit also exists. LHL is equals to RHL is equals to f of 0. Okay, so I hope it is clear. I have just taken one example. So if one is continuous, other one is discontinuous, sum and addition and subtraction is discontinuous, but multiplication or division can be continuous also. I am not saying it is always continuous, but in sometimes it can be continuous. So these are those of examples where it can be continuous. Okay. So now we will move to the next thing, that is, if both functions are discontinuous, then again addition, subtraction, product and division are not necessarily discontinuous, because generally we tend to see like both functions are discontinuous. So if we are adding, how can it be continuous? But it can be happen. Just you can see, like f of x is there. I have taken x is greater than equals to 0 pe 1. X is less than 0 pe -1. Okay, so at 0 it is discontinuous. Similarly, gx is also, but we have just changed the value. So both are different function. So if we will multiply both the function, okay, if we will multiply both the functions, so what we are getting? 1 into -1, it is -1, and -1 into 1, it is -1. If suppose we are adding both, like f of 1 plus g of f of x and g of x, so what we are getting in both, 1 plus -1, it is 0, and x is greater than equals to 0. -1 plus 1, it is 0 if x is less than 0. So you can see it is continuous, right? F of x minus g of x, what is coming? 1 minus -1, it is 2. And -1, it is -2. So yeah, it is discontinuous. But I am not saying ki always. So I have proved that one product is coming continuous and one addition is coming continuous. So any can be continuous also. It is not like blindly you can say ki yeah, it will be discontinuous. Not. Some of the cases it can be continuous. Okay. Now we have to see continuity of composite function. Okay, what is the composite function? So composite function, you already know, if there is a function inside function, right? So if g of f of x is continuous at x equals to c, means what? First of all, we are putting x value. So f of x needs to be continuous. So first I have written function is continuous at x equals to c. So now f of c will become what? The domain for g, right? Because we are first putting x, it is going inside function f of, and then after that it is going inside. So g is continuous at x equals to f of c. So if this condition is forming, then we can say that the composite function is continuous also, right? So now we can take one example, this one, right? So first of all, we have f of x, right? This is x square plus 1 divided by x square minus 1. And the other one is gx is equals to 10x. Now they are saying f of g of x. Check the continuity. Okay, so first of all, we have to see that whether gx is continuous or not. So I have to see when gx is continuous. So we know that it is 10x, and 10x is always continuous except the odd multiple of pi by 2, right? Because odd multiple of pi by 2 पे ये discontinuous होता है. So I can write x is equals to what? It is 2n plus 1 pi by 2, odd multiple. Okay, of pi by 2. Now we have checked in this point it is discontinuous. Now we have to check for f of gx. So if I will write f of gx, I can write like this. In place of x square, I will write gx square plus 1, and then this is gx square minus 1. Now in place of gx, what I will write? This is 10 square x plus 1, and this is 10 square x minus 1. Now we need to check for this one, right? So now again, if it is discontinuous, so definitely it is a trigonometric function, right? So this can't be equals to 0, otherwise it will be defined. So from here 10x will be coming as plus minus 1. So 10x value can't be plus minus 1, otherwise it will be discontinuous. So I have to check when 10x is equals to 1. So general solution, you know that x is equals to n pi plus pi by 4. And if it is 10x is equals to minus 1, so what is x value? It is n pi minus pi by 4. Okay, so you can see it can't be odd multiple of pi by 2, it can't be n pi plus pi by 4, and it can't be n pi minus pi by 4. So except these points, everywhere it will be continuous. Okay, is it clear everyone? Okay, yeah. So now we will check for the second one. Okay, this we have to find the points of discontinuity of y, that is 1 by u square plus u minus 2, where u is equals to 1 divided by x minus 1. So first we need to check for this. So x minus 1 should be 0, then x is equals to 1. It can't be 0 now. So this is your point of discontinuity. Point of discontinuity. Okay, now if we are checking for this one, so this can't be 0. I can simply factorize it, right? So either u plus 2 can't be 0, and u minus can't be minus 1 can't be 0. So if u is equals to minus 2, so we need to find the point of discontinuity in x now. We know that what is u? U is 1 divided by x minus 1 is equals to minus 2. So if we will find x, I know the solution, so I will write simply 1 by 2. And here it is what? 1 divided by x minus 1 is equals to 0. After finding, you will get x is equals to 2. Okay, so first we need to prove, we need to see whether this is defined or not. So here we have got one point where it is not defined, so that is point of discontinuity. After that, this can't be 0. After solving this, we have got two another points. So what are those points? One is 1 by 2, other one is 1, and third one is 2. So these three are the point of discontinuity. Is it clear everyone? बताओ जल्दी जल्दी से. Okay, yeah. Okay. So now we can solve some of the continuity part, because all of the discontinuity and continuity is over. Okay, so we can solve one thing like if function is continuous at x equals to 0, so find the value of a. So you know that any function is continuous. So what is the condition? Left hand limit is equals to right hand limit is equals to f of 0. Right, so you can find left hand limit like limit x tending to 0 minus, this is 1 minus cos 4x divided by x square. So if I will put 0 minus h, so what I will find, cos 0 4 into 0 minus h divided by minus h ka whole square, that is 0 minus h ka whole square. So we are getting 1 minus cos 4h divided by h square. After solving this, what you are going to get? 2 sin square 2h divided by h square. Now it is 2h, here it is h. We have to make 2h, right? So 4 into 4. So it will be 8. And why I have taken 4, you can see this is 4h square. I can write like 2h ka whole square. So this will become 1 and it is 8. Right? So if you know the limit and little bit continuity, you can see. And what is the f of 0 value? That is equals to a, right? So we don't need to find RHL. We have LHL, we have f of 0. So a is equals to 8. Okay. Okay. Similarly, we can see this one, guys. Like we have to find the function is continuous at x is equals to 0. So determine a and b. So what we need to do, we can find LHL. LHL means what? Limit x tending to 0 minus. So now no need to always put 0 minus h, just solve this limit. Just solve this limit. This is a divided by mod of sin x. So if I will put 0, so it will be coming as 1 plus 0, a divided by 0, 1 to the power infinity. If you know the 1 to the power infinity, you should know the format how to solve it. If this is f of x, if this is g of x, so 1 to the power infinity it is coming. So it will be e to the power f of x minus 1. It means 1 plus mod of sin x minus 1 into gx, that is a divided by mod of sin x. So a cut gaya, sin x cut gaya. So what you are getting? E to the power a. LHL value. What is f of 0 value? F of 0 value is b. Right? Now we need to find the RHL value. So what is 0 plus? It is e to the power 10 2x divided by e to the power, divided by 10 3x. So like limit x tending to 0 plus e to the power 10 2x divided by 10 3x. So what I will do, I know you have some idea how to solve this, right? Whenever you are seeing 10 2x divided by something 10 3x, you can do like this. Divided by 3x, multiply by 3x. So this will become 1, this will become 1, x will be cancelled, it will become e to the power 2 by 3, right? So now what we have? We have LHL, that is equals to e to the power a. We have RHL, that is e to the power 2 by 3, and we have f of 0, that is equals to b. So if we will compare all these things, if it is continuous, so a will be coming as 2 by 3 and b will be coming as e to the power 2 by 3. Is it clear, everyone? I just want your responses if it is clear. Is it clear? Chanvi, Rajkot, Silvassa, YouTube people. Okay, so similarly you can solve these questions, guys. ये questions कर लेना आप लोग. Okay, you can take the screenshot of it. Okay, LHL RHL निकाल के f of 0 में equal कर लो. Then This question also can be solved like LHL. You can use the sin x by x ka formula. In the RHL, you can use the rationalization, and after that, you will get two equations. From there, you can find P and Q. Okay. So yeah, so that's it for the continuity part, and I have not finished yet because uh, first I will try to show all the theories part, and then after that, one class I will take the combined problem solving on continuity and differentiability and method of differentiation. Okay, but theory part we need to finish as quickly as possible. Okay, so what is differentiability? So differentiability is basically, it is nothing but differentiation only. If we can differentiate any function, it means that function is differentiable. Okay. Like you know what is the geometrical meaning of differentiability? It means geometrical meaning of differentiation is nothing but it is rate of change. Means it is change in something with respect to change in something, like change in dependent variable with respect to change in independent variable, like dy by dx. Okay, so in this case, what is the differentiability is nothing but derivability. We can also say derivative also. So what we need to do, fx, if derivative it is f dash x, so it is nothing but change in y with respect to change in x. And if the change is very small, means delta x is tending to 0, so we can write change like y2 minus y1 divided by x2 minus x1, where y2 is what? X plus delta x, f of x plus delta x minus f of x divided by delta x. If this limiting value is coming as finite value, then we can say that limit exists. And also we can say that the function is differentiable. Okay, so there can be two kind of changes. One is negative changes, other one is positive changes. Okay, so negative changes it coming. So you can see here. Here you can see f dash x, delta x is tending to 0, change in x minus delta x. Okay, and minus delta x. So it is called as left-hand derivative. And if it is positive changes, we can call it as a right-hand derivative. Okay, and if all this left-hand derivative and right-hand derivatives is equal and it is finite value, then we can say that the function is differentiable. So I am just showing you the next slide. Here you can see there are two types of meanings of differentiability, or you can say derivability. One is geometrical meaning of derivative. You know that derivative means dy by dx. So it is nothing but slope of the tangent. Okay. Okay. And physical meaning of derivative means what? Rate of change of function, yani dy by dx. Okay. So what we have done, you can see that there is a function. Okay. This is the function, this is the a value. Okay, so in this part, in the right hand side part, what I have taken, there is a change in a plus h. Okay, a plus h, small change, that is h. So a plus h, and here it is. So what we will write, the general we will write, right, for right hand derivative I will write f of a plus h minus f of a divided by h, where h tending to 0 plus, and this can be written as f dash a plus, so that we can say that, oh, a plus means right hand derivative. Similarly, if we'll go left hand side, you can see there is a change in negative change. Okay, so first it was a, now it is a minus h. So definitely the change will be final minus initial, means a minus h minus a. So a will be cancelled out, it will be minus h. So that's why you can see if f dash a minus is there, there is minus h. Okay, and in the right hand derivative it is plus h. Okay, so I hope you know this, right? So if LHD is equals to RHD is equals to finite quantity, so we can say that the function is differentiable at x is equals to a. This is also called as f dash a minus, this is f dash a plus. Okay, so these are the basic formula that you need to see. Like this, you can see The basic thing is if any function is differentiable at x is equals to a, so what should we have? What should happen? It should happen like right hand derivative, that is f of a plus h minus f of a divided by h, or left hand derivative, that is f of a minus h minus f of a divided by minus h. Then we can say that the function is differentiable at x is equals to a. Okay. Okay, so we can see the first problem. Okay, we have to say that the f of x is equals to mod x is not differentiable at x equals to 0, right? So what we need to do? So we need to find LHD, right? We know the graph also, right? This is the mod x graph, but we will find by the normal method LHD, that is limit x tending to 0 minus, so it will be f of 0 minus h minus f of 0 divided by minus h. So what is this f of minus h minus f of 0 divided by minus h? So what is minus h? It is minus mod of minus h minus 0 divided by minus h, right? So if we will find, it will be minus h, mod is h only, minus h, so it will be coming as minus 1, right? Right. Similarly, if I will find right hand derivative, so limit x tending to 0 plus, it will be coming as f of 0 plus h minus f of 0 divided by h, by the formula. So it will be again f of h minus 0 divided by h. So it is mod h divided by h. So h by h is equals to 1. So it is minus 1 and it is plus 1. So LHL is not equals to, sorry, LHD is not equals to RHD. So we can so say that it is not differentiable at x equals to 0. Okay, and but there is one more thing so that we can find if any continuous function is given and at any point if is there any sharp turn or sharp corner, then we can say that the function is not differentiable. Like you can see, this is the graph, this is a continuous function, but here at around x is equals to 0, there is a sharp corner. Okay, so if there is a sharp corner, but only in case of this continuous function. Okay, because after the next slide, I will show you how. Okay, so if you are checking through graphically, right, by the graph also you can say without doing this much calculation. Okay, if there is any sharp corner in any kind of continuous function, continuous, it should be continuous first, then we will go for sharp corner. Okay, if it is discontinuous, then it can't be differentiable. Okay, because every differentiable function needs to be continuous. That I will show you. Okay, this one also you can solve. Right. Check the differentiability of the function f of x is equals to x plus 2, x is greater than 3, 5x is equal to 3. Like you can find LHD, you can find RHD by finding that formula. But I will tell you one another formula that is short one. Okay, like f dash. Okay, f dash. If you will find f dash, so what you are going to get f dash 3 minus. Okay, so what you need to do, just do the derivative f dash 3 minus, right? So if x is less than 3, it is 8 minus x now. So what you need to, if we will do the derivative, what is f dash x? It will be 8 0 and minus x is minus 1. So f dash 3 minus will be what? It is minus 1, right? Just do the derivation. And RHD, that is right hand derivative f dash 3 plus. So what is this? It is x plus 2. Then it is what? What is coming? Okay, it is 1 only, right? So 3 plus. So it is 1 only. So again, you can see minus 1 and 1. Then LHD is not equals to RHD. So we can say that at x equals to 3, it is not differentiable. Because I know that f of a plus h minus a, that is the formula. but that formula is giving you the value that you are getting after doing the differentiation. If you'll do the differentiation also, it is easy. So I am just saying you, whenever you see, don't always find LHD and RHD, just do the derivative of that function and just put the value, you will get LHD and RHD. Okay, I will show you. Okay, like this one. Okay, I have to check the differentiability. So what I will do, okay, first of all I have to check whether it is continuous or not. So for the continuous, I have to check LHL is equals to RHL. So I have to check at x is equals to 1. What is the value? This is LHL is equals to 3 to the power 1. So it is 3. And RHL is what? It is 1 plus. It means 4 minus 1, that is 3. It means, yeah, LHL is equals to RHL. Okay. And also, what is the f of 1 value? It is 3 to the power 1. So it is 3. So it is f of 1. So it is continuous. Okay. Now we have to check for the differentiable. Okay. So what I will do? I will simply do this derivation. So f dash x. So what will happen? F dash x will do, it will be 3 to the power x log 3, right? 4 minus 1 to 1. And if I will do the derivative of this, it will be 4 minus 1. Okay, just do like this. Okay, no need to always write f of 1 plus h minus f of h divided by h like that. Don't do this. Just find the derivative. You know the differentiation, basic differentiation, right? A to the power x is a to the power x log a. And then just put the value. If you will put 1, what you are going to get? It will be 3 in power 1, 3 log 3. And here if you will put 1, then what you are getting, you are always getting minus 1. So you can see LHD is not equals to RHD. If it is not equals to RHD, because this one is LHD and this one is RHD. So we can say that it is not differentiable. Okay, it is continuous, but it is not differentiable. Okay, I hope it is clear. Okay, so there are some formulas. And then after that, I will solve 2-3 problems because we have some time left. Okay, so first of all, what is the relation between differentiability and continuity? So first thing that you need to keep in mind, that if any function is differentiable, then it needs to be continuous at that point. Okay, if every differentiable function is a continuous function, every differentiable function. Okay, but the reverse is not true. Like all continuous can't be differentiable, but every differentiable will be a continuous function. Okay, because I was talking about the sharp corner, right? In the sharp corner, what was happening? The function was continuous, but it is coming sharply. Okay, sharp corner, there was sharp turn. So that's why continuous can't be differentiable always, but differentiable function will always be continuous. Okay, just keep these things in mind. Okay, so these are the some notes that will be help you, like f dash a plus, suppose LHD is p, RHD is p, LHD is q. If both are finite, then we can say that at x is equals to a, it is continuous. If it is differentiable, if it is not equal, then it is not differentiable. And one important point that I have told you, that function may still be continuous, but it can't be differentiable. So in this case, what you need to do, you just need to draw the proper graph. If any function is continuous, but if it is not differentiable, then in the graph you will see so many times that there is a coming sharp turn, like this one. Like suppose I am drawing this graph like this one. Okay, so you can see there are so many sharp turns there, right? We will see some problems like that in the upcoming classes. So there are 4 points where there is a sharp turn. So this function is continuous function, right? But there is a sharp turn. So there at the 4 points, it is not differentiable. At the 4 points, it is not differentiable. Okay. Okay, so these are the points that you need to keep in mind. And the other thing, just like continuity and in interval, it is differentiability in an interval. If any function is said to be interval in an open interval, so what you need to do, it should be differentiable at every point of the interval. Okay, in that interval, each and every point of intervals, we have to find the differentiability. Okay, it means what? At every point, first it needs to be continuous, then only it will be differentiable, right? And the other is, if it is differentiable in closed interval, so what we need to do? We need to check the differentiability at every point in between A and B, but there is closed interval. So at the boundary point, that is A and B, at that point you have to check. At A you have to check right derivative, because left will be not applicable, and for at B you have to check the left derivative, like this one. Like suppose there is a graph like this one, and this is A and this point is B. Okay, so if we have closed it like B, A, so we are not going this side and we are either not going this side. So for A, what will happen? Only right is happening, and for B, only left is happening. So for this, you have to check right hand derivative, and for B, you have to check left hand derivative. Okay, and then all the points here, you have to check left hand derivative and right derivative both. So if it is happening, we can say that the function is differentiable at each and every point. Okay. So one problem we will see. Okay. Then we can easily understand. Okay. So this one. Check the differentiability of the function at x is equals to pi by 2. Okay. At point pi by 2, what? So what we need to do? So just I will tell you the one formula. What you need to do, just find f dash x. Okay, so f dash x you will find, so 1 it will become 0 if it x is less than 0. For 0 to pi by 2, 1 plus sin x, it will become cos x. 1 ka 0, sin x ka cos x. And for this one, what you need to do, it is 2 ka 0 and then 2 into x minus pi by 2. So it will be 2x minus pi. Okay. So now at what point we need to check? At x is equals to 2. So sorry, pi by 2, right? So LHD, it means limit x tending to pi by 2. Okay, it is what? F dash pi by 2 minus, right? So pi by 2 minus means what? It is cos x only, right? Pi by 2 minus. So I can write like this, cos pi by 2 minus h. Right? Cos pi by 2 minus h. So it will become what? Sin h. Right? And similarly, if I will find RHD, it is limit x tending to pi by 2 plus. So if it is what? F dash pi by 2 plus. So pi by 2 plus means it is coming in this one, right? This one. This interval. So what will happen? 2 into, here I can write pi by 2 plus h minus pi. So after cancelling this, you will get pi plus 2h minus pi. So pi will be cancelled out, and 2h, it will become what? 2 into 0. So it is 0 only. And this is sin h. If h tending to 0, it is also 0. So from here you can see what is coming. LHD is also coming as 0. RHD is also coming as 0. So LHD is equals to RHD. So I can say that, yeah, this is differentiable at x is equals to pi by 2. Okay, so this is the method that I have told you regarding that. You can easily solve. Otherwise, what you can do, you can simply use that formula also, that is f of pi by 2 plus h minus f of pi by 2 divided by h for right hand derivative, and for left hand derivative you can write f of pi by 2 minus h minus f of pi by 2 divided by minus h. but it is easy because what we need to do, we just need to derive take the differentiation, and then after that just check the interval. If it is pi by 2 minus, take that function cos x. If it is pi by 2 plus, take that function, that is 2 into x minus pi by 2 or 2x minus pi. Okay, so I hope it is clear. Okay. Okay, so we can also see derivative of composite function, like if there are two function is differentiable at any point. So if we will take the composite function also, f of g of x or g of f of x, so it will be differentiable at that point only. Okay, it will be differentiable. Composite function will be also differentiable. Okay, so these are the some theorems of differentiability. If two functions are differentiable at any point, then addition of both the functions, subtraction of both the function, multiplication of both the function, or division of both the function will be always differentiable. And the second case, if one function is differentiable, other function is not differentiable, then the addition or subtraction of the function will not be differentiable. Okay, but product, we can't say anything about product. Okay, for the product it may differentiable. Okay, so these are the basic algebra. Okay, like if both f of x and g of x are not differentiable or derivable, then we can't say anything about some difference in the product. Just like the continuity we have seen, we can check it. Okay, we can just remember it. Okay, like if both functions are differentiable, not differentiable or not derivable, so some difference and product can be differentiable sometimes, not always, but in sometimes. Okay, we can't blindly say that if both are not differentiable, then some difference and product will also be not differentiable. It is not like that. In some of the cases, it can be differentiable. So you can see one example like that also. Okay, is there any doubt, guys? I know this is a crash course class, so I need to go fast. Okay, I'm trying to explain, but few concept that you can remember that I am actually removing. Okay, not removing, but I am showing the slide so fast. Okay, so this is the important result that you need to remember. Every polynomial function, constant function, and exponential function is always differentiable at each x is equals to x belongs to real number. All the logarithmic, trigonometric, inverse trigonometric functions are differentiable in their domain. Okay, all are differentiable. Okay, so when you are solving JEE problems, at that point you don't need to always find like this. These kind of function, if you will see, you can consider that it will be differentiable. Okay, and the sum, difference, product, and quotient of two differentiable function is differentiable. Every differentiable function is a continuous, but converse may not true. All continuous functions are not differentiable, but all differentiable functions are continuous. Okay, so these are the some examples that you can see. These are the differentiable functions like exponential function, logarithmic functions, trigonometric functions, okay, hyperbolic functions. So these are the things we need to see. Okay, so one more problem that I will solve and then we will stop the class. Okay, so we have f of x, okay, and we have to find the value of a and b if f of x is differentiable everywhere. Okay, so what we need to do? First, we will find f dash x. Okay, find f dash x. So after finding f dash x, what you are going to get? 2ax minus b. Okay, and the second one is what? 2bx. Okay, if x is less than 3 and if x is greater than equals to 3. Okay, so now we have to find LHD. So if I will find LHD, so I have to take 3 minus. So it will be 2 into 2a, 3 minus h minus b. So it will be what? 6a minus 2ah minus b. It means if you will see h, it will be 0. It will be 6a minus b. Similarly, for right hand derivative, it will be what? Limit x tending to 3 plus. So we have to take this function 2bx. So it will be 2 into B into 3 plus H. Okay, so what it will be, H is equals to 0, it will be 6B. Okay, and I have told you कि we have to take the value A and B so that the function is differentiable everywhere. It means if it is differentiable everywhere, so LHD needs to be equals to RHD. It means left hand derivative should be equals to right hand derivative. So it will be LHD will be equals to RHD. So from here we will get one equation, that is 6A minus B is equals to 6B. So 6A is equals to 7B. But still we are can't able to find A and B. So what we need to do? So one more thing that you already know, that we need one more equation, right? So we know that if the function is differentiable, then definitely it is what? It is continuous also, right? It is continuous also. So from continuity part, we will find one another equation, that is LHL equals to RHL. So if I will do LHL, here I am just writing, if I will write LHL, so what I need to do, this 3 I will put, it will be 9A minus 3B plus 2. And if I will do, I will find RHL, it will be 3 ka whole square, this is 9B minus 3. So if it is continuous, then both should be what? Equal. Like we can write 9A minus 3B plus 2 is equals to 9B minus 3. So here what we will get? 9A minus 12B minus plus 5 is equals to 0. So this is your first equation and this is your second equation. After solving these two equations, because if it is differentiable, it is continuous also. Okay. So solve this equation and find A value and B value. Okay, so whenever these kind of question is there, if it is saying as differentiable, if you are getting only one equation, so you know that it is continuous. So just apply the continuity formula also. From there, you will get one another equation. Okay, so that's it for the today's class, guys. Already the time is over. You can solve this problem also. Again, here also same thing you will apply, like if it is differentiable, so one time you have to do the derivative part, like just find g dash x and find LHD is equals to RHD, and the other one is you have to find LHL is equals to RHL. Okay, so from there you will get two relation in K and M. After solving this, you will get K value and M value. Just add it, that will be the value. So the answer will be A. Okay, so you can screenshot it, you can take the pictures, or in the previous year questions, if you have any books, you can go through it and solve it. Okay, so we will solve one day, we will keep complete JEE problem solving. From there, you will get the clarity of all the concepts. Okay. So thank you everyone. Thank you for your time. We will meet in the next class. Thank you. If is there any doubt, just let me know through the chat box. So thank you Janvi Vijayanagaram for participating in today's class. So initially you were there, you told that there were 40 students, but I hope you were watching through YouTube, okay? Because I couldn't see, because you guys have joined very late. So I hope you were watching through YouTube. Okay, otherwise you can go through the YouTube link, that is Avanti Live 3. From there you will get this link, okay, from start. So thank you. We'll meet in the next class. Okay. Thank you. Is there any doubt? You can ask, otherwise you can leave. Thank you, everyone. Thank you.